Hello everyone, welcome to the Know About Electronics channel. This is our fourth lecture of the electronics. Here we are going to take the concept of forbidden gap or energy gap. This is the channel where we are discussing about the some things which are necessary and which are good for the electronic students, and it's also having the good knowledge about the some important concepts. So be with the Know About Electronics channel. So without wasting time, let's start the today's video. So today we are going to have the knowledge about what is meant by forbidden gap or energy gap. So I'm going to take here an atom. Okay, this is an atom. Every atom, particular atom, having the atomic value. Okay, here I am drawing the atomic. Here is the atom, and these are the atom's shells. Okay, in this atom there is the proton and nucleus are present, and in the outermost these shells it's having the electrons. This is called as a electrons. Okay, when so what is meant by forbidden gap or energy gap? So if your outermost shell is having a electron, and that electron you have to send or you have to conduct to the another level or another band, some energy must be required to throw out this electron from this shell to the another bond. So whatever the energy required to deliver this atom, this is sorry and not atom, electron to the another band, whatever the energy required, it's known as the energy gap. Okay, so simply we can draw this like this. This is suppose valence band, that means this band. Okay, this shell, outermost shell having the electrons, so that is called as a valence band. Valence band, and you have to deliver this valence band to the another band, so that band is nothing but the conduction band. Conduction band, and this gap is nothing but the forbidden gap or energy gap. Why it is called as forbidden energy? Because to throw out, to deliver, to conduct the electrons in the valence band to the conduction band, whatever the energy required is called as energy, and this gap is called as the energy gap. Okay, so the insulator, the conductor and the semiconductors having the energy gaps. So we will see how much amount of they are having the, or how much quantity of they are having the energy gaps. Okay, so first of all we will see about conductor. As I said you, that conductors having the more electrons in, because it allows to flow the electrons. Okay, so in conductor there is a no forbidden gap is present, because the valence band and the conduction bands are overlapping due to high population. In the conductor there is a, as we have seen in the last lecture, that city A, city B, city C, that time we have saw that conductor having the more population, that's mean it's having the more electrons in, that's why there is no energy gap between the valence band and conduction. It's a completely overlapping on each other, so there is no energy required to fill this energy gap. Okay, this is about conductor. Then we will take the example of insulator. Insulator is not allowing the electrons to flow through it, so it's having the more energy gap. This is a energy gap. Okay, means you have to provide a more amount of energy to this type of valence bond electrons to pass out from the VB to CB. Okay, so how much it is required? Insulator is having the energy gap to 5 electron volt, means 5 electron volt energy you have to provide to deliver the electrons from valence band to the conduction band. Now electron volt, how it comes? That is force, means energy required to push out or to apply to this electrons in the valence band. So force is nothing but the Q into A. Okay, so Q is nothing but the charge, electron, and the electric volt V, electric supply. Okay, so it's equal to electron volt. Force is measured in electron volt. So how much amount of 5 electron volt we required to deliver the electrons from valence band to the conduction band? So it's a more energy required here. In the last but not the least, semiconductor, it's having the both property of conductor and insulator. That means also allowing the electrons to flow, but with that one it's also having the property of insulator, that it does not allowing the electrons to flow in the much quantity. Okay, so it's having the forbidden gap present here, but only in a limited quantity. Okay, here you can see I have give the two spaces because I want to denote that here more energy gap is required, here no energy gap is required, and here I have taken the 1.5 one. So here required the not more than the conductor, and not more than the insulator, and not less than the conductor. Okay, so how much it requires? Requires about the 1 electron volt, means less than the insulator and more than the conductor. Just a 1 electron volt you have to apply to this electrons, then this will deliver the electrons of this band to a conduction band. Okay, in this way. Okay, now it's how much quantity of the energy you have to apply. It depends on the materials whatever you are going to use. Okay, in conductor, in insulator, in semiconductor, suppose in semiconductor you are going to use the silicon material. Okay, to silicon material the valence, the energy gap for it is a 1.2 electron volt. If you are going to use the germanium, then it's for zero point 0.7 electron volt. Means in this, if you are going to use the silicon type of material, then that time you have to provide the 1.2 electron volt to start your functions of that material. And germanium, it's having the 0.7 electron volt. It's requires the less energy, so most of the materials are going to be used with germanium and with the silicon. Okay,